Now we are going to welcome Tamas Sabo. Tamas works as a research engineer at GitHub Next, which is a research lab within GitHub exploring the future of software engineering. He is involved in a number of Next explorations centered around AI-assisted developer tooling. He's going to talk about Copilot Workspace, a reimagined developer inner loop with AI assistance at every step. Let's give a really warm round of applause to Tamas Sabo, the first Hungarian in this stage.
Thanks a lot. I appreciate that you took the effort to come here with this weather. And also thank you for the introduction. So I work at GitHub Next. This is a small research lab within GitHub. We are roughly 20 people. And our goal is to take a research idea and then do an exploration. Essentially, for a couple months, you're exploring the idea. Our primary goal is to create a software prototype, hoping to prove the usefulness of the idea. But it's also a valid outcome if we actually find that the idea is not promising enough. Then we just simply stop exploring that idea, and then we move on to the next one. You have probably heard about Copilot. Copilot was incubated in GitHub Next, roughly for a year, and then it was handed over to an engineering team afterwards. Copilot Workspace is one of these projects that we are carrying out at GitHub Next right now. It is in technical preview phase at the moment, and I would like to give you essentially a live demo first, how it works in action, and then explain a little bit about how we work at GitHub Next and how we actually conduct research centered around Copilot Workspace. So I'm going to start immediately with the demo. This is a standard GitHub repository called Contributor Gallery. It is a web application. The purpose of this application is to type in here the name of a GitHub repository, and then it will display all the people, the avatars of the people who actually contributed to that repository. Every second or every 2 seconds, it actually highlights one of the avatars. Nothing fancy, but this will do it for the demo for now. I'm going to go here to the issues part, and there is an issue here that I would like to show you. Show GitHub handles when a gallery cell is active. Essentially, the idea here would be that we want to add an extension to this web application so that instead of just showing the avatar of the user, we would also like to highlight the GitHub handle of the user, thereby giving kudos to the developer. Now, there's a description of the feature here. There's some comments going on. And what I want to do now is to actually use Copilot Workspace itself to solve this issue. You can imagine GitHub Copilot Workspace as a lightweight IDE in the web, essentially with AI assistant at every step. We start from a GitHub issue, and we guide the user all the way through a GitHub PR. At every step, the user is in control. The AI's output can be steered and iterated on. And essentially, thereby, we want to do an exploration with the user and end up with a solution that you can send to other reviewers to gather feedback. So I'm going to click on this button here, Open in Workspace. You can see that this navigates me to Copilot Workspace and already the issue that I talked about that is in context. There's a timeline displayed here. We start with the issue description first. You can see there's nothing surprising here. Here's the issue title that I just showed you. There's the issue description. There's the image here. What is important is that Copilot Workspace actually knows more about your issue and your repository than what is shown here. It also knows about the files in your repository, and it can essentially, it is very good at collecting all the context that is needed to solve an issue. There are different entry points to Copilot Workspace. This is just one of them, starting from an issue. But you could also start from a GitHub PR, for example. Imagine the scenario that you already created a PR and you gathered some feedback, and now you would like to get essentially work more on the PR based on the feedback. That's also possible, so you can start from a PR. Alternatively, the third option is to start from manually crafted tasks. So I could put together essentially my own title and my own description, thereby starting an exploration. Once we are OK with the issue description, we can move on to the next step, which is essentially coming up with a specification. The specification is describing the current behavior of the system, and it also tells me the proposed behavior, which is essentially how the system should work once the issue is implemented. What is very important here is that every step or every content in the specification panel is actually editable by the user. So I can go ahead and add new items, I can delete items, I can modify the indentation just to have it better readable. The user is in control. First, we start with a question. Does the gallery cell display the contributor's GitHub handle? Here's the current behavior. No, it doesn't. There's this file which is doing something in this direction, but it's only showing the avatar, and so on. The proposed behavior now says that, yes, the gallery cell displays the GitHub handle. This file will be modified with a new component. That component will have appropriate styling, and so on. There's an important button here, View References.
Just a minute, I have to change your...
All right. So what you see here, these file references, this is essentially the slice of the repository that Copilot deemed important to solve the issue. Essentially, you can see here 19 files are listed. This doesn't mean that all these 19 files will actually be modified by Copilot Workspace. These 19 files represent the slice of the repository that the AI will actually see in terms of the file contents. This was selected essentially by the AI with an appropriate prompt, but essentially this is where the exploration begins. This is also modifiable, so if you want to put a different file on the radar of Copilot Workspace, then that's also possible. Once we are OK here with the specification, we can move on to the next step, which is about generating a plan. The plan here is now a detailed description of all the files that will be changed and how they will be actually changed. You can see that the contributor gallery cell TSX file, that's the only one that the AI wants to change. And then here are the actual changes. We introduce this new component, GitHub handle, we add styling, and so on. If you want, you can actually add other files that you find important that Copilot Workspace should modify. You can even specify what kind of change you expect. Alternatively, you can add general notes about the implementation, which would, for example, give a hint to Copilot Workspace what kind of testing library to use, what kind of API to use, and so on. If you don't like the plan, you can essentially completely re-roll it, regenerate it with Copilot Workspace. Alternatively, you can just go ahead and modify these bullet point items. So if you're OK with the plan, we can move on and actually implement the selected file. There's a single file right now. You can see that this is where we're actually talking to the large language model behind the scenes, and we are retrieving the new file content. This file has 45 lines in the current version of the repository. And then Copilot Workspace, you can see that there was a counter here. It essentially added like 13 or 15 new lines. The left-hand side, this is essentially the original file content as it is in the repository. I cannot modify this, so this is a read-only version, just so that you can see in the diff viewer how it looks like right now. And on the right-hand side, you can see the actual changes. This is where this new GitHub handle component is used, and here's the component itself. Now, I don't know if this code change is actually OK. I can, by the way, go ahead and add new code changes here. So the right-hand side is actually modifiable. What I want to do now is to actually have a way to actually try out this code change. You can actually start up a terminal here in Copilot Workspace. What is cool about this terminal is that this is actually backed by a codebase. Codebase is an existing product of GitHub. You can imagine it as an on-demand spun-up virtual machine. Essentially, I can throw away if I don't need it anymore, and it is created for this Copilot Workspace exploration. I can go ahead and actually type commands here. So for example, I can actually see that the changes that I made here in the web client, or actually AI made, those are carried over to the code space. There is bidirectional file syncing going on between the web client and the code space, so I can just hand off and go to the other side of the system if I want to. I can also just execute commands here. For example, I can actually try and build or compile this project. Let's see if that works. Once again, the command that I issue now that is actually executed in the code space, that is the computational power that we have here. So the compilation was successful. Now I want to go ahead and actually open up the code space from here. You can see this is where I go to the other side of the system, and now we have a full-blown VS Code, which we can use if we want to. And we can stay in the web client, but I really want to actually start running this application. And for now, for me, VS Code is better suited for that. So while this is starting up, it takes like 10 seconds. Or actually, maybe it's already ready. Yeah, OK, this is fine. You can actually see that this is the clone of a repository, except the change that we made here in the web client that is carried over here. So there's a single change file. If I would go ahead here and make some changes, Oh, my keyboard layout changed. You will actually see that after a couple seconds, that is carried over back to the web client. This is what I was talking about when it comes to file syncing. So I'm going to go ahead and actually start the application. What happens when I issue yarn start is that port forwarding will kick in, and I actually see the web application running live backed by the code space. So this is how it looks like right now. You can see that the avatar is highlighted. There's also the text displayed here. It's hardly visible, though. So this is not yet the solution that I want. Now I actually want to make a change to make the text appear in gold color. Obviously, I could go ahead here and then make the change in VS Code itself by myself or in the web client. But instead of doing that, I would actually like to use Copilot Workspace to do this change for me. So I'm going to go back. And actually, I will go back all the way to the plan. And here I will add a new item. Make the text appear in gold color. I can go ahead and update the selected file, the implementation. Let's see what happens. Again, this is when we are talking to the language model to retrieve the new file content. And Copilot Workspace actually highlighted for me this part here. This is updated color to gold. Now, the interesting thing about this is I don't actually see the color gold show up in the text. So I'm hoping that Copilot Workspace knows what it's doing, because to me, it doesn't seem right. Let's see. We can actually give it a try. You can see, by the way, that the change was carried over here also to the code space as well. So I'm going to go ahead and try to compile the project again. And afterwards, I want to run it again. So port forwarding again. Let's see. You can actually see that this is now gold. So this pretty much resonates with the keynote presentation from this morning, because really what happened here is that I was programming in natural language. Copilot actually knew better what is happening in the code base, because it knew that there is actually a special color in this theme, which is the gold color. And it actually made use of that. I didn't know about this, so Copilot Workspace actually did a good job here. Now, when it comes to leaving Copilot Workspace, there are a couple of exit paths. So we can actually create here a snapshot. You can imagine this is a Google Doc-style link, a sharing link that I can give to others. You can actually see here at the very end that there is a long hash. This identifies the session that I have been carrying out here in Copilot Workspace. If my fellow developer has access to the same repository, I can just give this URL to them, and then they can essentially reconstruct the entire session that I have conducted here, and they can see how I ended up with those changes. Alternatively, I can go ahead and either create a branch with my changes, or I can create a pull request. Once I click on that button, you can see this panel show up. I can select the branch name. There's the title auto-generated for me. There's also the description, which is auto-generated. Obviously, you can actually modify that. And at the very bottom, here's the sharing link that I just talked about for traceability purposes, so that even from the GitHub PR, developers will be able to navigate to this session and then see what happened. This is all I have for the demo. Let me switch over back now to the slides. So if you think about Copilot itself, it's Copilot, not Copilot Workspace. It's hugely popular. So we have millions of users, active daily users now. And Copilot, we really think about it as the first generation of AI tools. So it's really good at helping you with repetitive and boilerplate tasks. It's really good at suggesting how to use APIs. But Copilot Workspace, what we think about it is that this is going to be the second generation of AI tools. And when we were coming up with the design of Copilot Workspace, we really wanted to understand what developers even think and expect from an AI-assisted tool. This is why we conducted a study with real developers at GitHub Next. I mean, the developers were not from GitHub Next. I would like to highlight the results of this study. By the way, this QR code will lead you to a GitHub blog post, so you can actually read all about this survey if you want. But I just would like to highlight the most important takeaways. When it comes to AI agents and AI-assisted developer tools, what developers really want is the AI to be a second brain, helping the developers to parse information, summarize context, present trade-offs, essentially come up with a specification. It's very important that they have a strong attachment to the complex thinking tasks, the understanding and the learning of the system. We don't want to take away that from the developers. This is a guiding principle for us. And developers are concerned that otherwise these fully autonomous AI systems, if they would do that, they would lose the understanding of the system. And that's bad, because essentially they would have no idea about what is happening, why it is happening. It's hard for them to reason about the system. And as you heard from the keynote this morning, we really need to be judges of the AI's output. And if we don't have an understanding of the system, it's going to be very difficult to do that. So the goal for the partnership when it comes to Copilot Workspace and the developers is that we want to lower the high cognitive cost so that it's easier to get started with a GitHub issue, but then the learning and the understanding, that should remain with the developers. And this is important because, for example, when it comes to other AI-assisted tools like Devin, which promises to take an issue and automate the complete solution with one click, that's not what we want here. We want Copilot Workspace to be a second brain and pair with the developer along the way. Developers will actually need to become system thinkers, so they will be actually able to have a complex understanding of the entire system, and probably they will be able to modify parts of the system that they may have not knowledge about. For example, when we develop Copilot Workspace, we use Copilot Workspace itself a lot. And I myself lean more towards the back-end side of things, but with Copilot Workspace, I was actually successful at solving front-end issues as well. There is this nice tweet from Greg Brockman, which again resonates with what I'm talking about here. Programming is so fun because you get to go from lack of understanding to mastery time and time again at a rate that is determined by your speed of iteratively writing and running code with real-world impact in the end. So essentially, we are here to support you from this lack of understanding to mastery journey. We lower the mental tax for getting started with an issue, but we do not undermine the learning process. Again, to recap the workflow, what I showed you in the demo, we start on a GitHub UI, either from an issue or a pull request. We enter the realms of Copilot Workspace in the web client, and the first step is coming up with a specification. The first version of the specification is produced by the AI, the large language model, but then the user can actually iteratively refine that and then make further changes, regenerate with the AI again and again. At this point, we identify the context in the repository. So this is essentially the issue description, the commands, and very importantly, the file selection, because that will determine what the AI sees from the repository. Also, we crawl links in the issues to some degree because we want to get as precise with the context as possible. Then we move on to the plan. Here with the planning, again, this is an iterative process. We can actually use natural language to program, and we can do refinement. And then finally, we have the implementation. With the implementation, we can even, on demand, spin up a code space. So we actually have a full-blown VS Code there, if we want to. And this is how we can actually develop. There's bidirectional file syncing going on. So whatever you do in the web client, it's going to be carried over to the code space and the other direction as well. Once the implementation is OK, you can actually create a PR or a branch, and then you go back to the GitHub UI, where now you can invite fellow developers for further feedback. At the super high level, I just want to briefly show how the architecture looks like. Obviously, there's a Copilot Workspace server which manages all of these things. Multiple Copilot Workspace clients can connect to that. We use the existing GitHub infrastructure to clone the repository, retrieve the issue commands, essentially all the details about the context. It's very important for privacy and security reasons that we do not actually keep a clone of the repository on the Copilot Workspace server. We use a Redis cache to essentially cache the file selection, the slice of the repository that is important. But the time to live is very short. Really, it's only live until your session is valid. So that's like a day. Then we have the code space that we can start up on demand. The code space is also talking to the GitHub infrastructure to clone the repository. And then the Copilot Workspace server is connected to that to sync the file changes back and forth. The file changes themselves, just the diffs, those are stored in Cosmos DB. And in the current implementation of Copilot Workspace, we are talking to GPT-4. And all of these things are actually deployed to Azure. So we have an Azure deployment for all of these components. Now, moving on, I would like to talk about two areas that are important, I think, because this is how you can understand how we iteratively refine Copilot Workspace. And so the first thing is the file selection and what we do there. The goal of the file selection is take the entire repository and identify the slice that will be important for your issue. Now, when it comes to prompting the model, you can imagine in a very simplified manner, the prompt looks something like this. We start with a description of the issue and the comments first. Then we have the list of all the file paths from the repository, prepended with an integer ID. And then we prompt essentially the model with instructions for the file selection, what needs to be done. Here's an extract from a real prompt. Essentially, you can see here file paths from a real open source GitHub repository. Doesn't really matter which repository it is, but you can see a bunch of file paths. Instructions are intentionally elided, but what you can see here at the bottom, this is actually the answer from GPT-4, a bunch of numbers, which is what we expect because we are prompting for identifiers of file paths. We are asking the model to print out which are the files that are important given the issue. What you can probably not see is that here at the bottom of the answer, at the end of the answer, there are increasing and decreasing sequences of numbers. That's total garbage. Probably like the first 6 or 7 identifiers, those are OK. But then the model kind of gave up and started just printing out these dummy numbers. And we see that a lot. Increasing and decreasing sequences of numbers, repetitions. Problem is that we are wasting valuable slots, because when we are asking for like 20, 30 file passes, maybe the first 5 or 6 are relevant and the rest is not. So the question is, what can we do about this? I want to show you now a benchmark run. I have here a link. We are actively using GitHub Actions to automate all sorts of benchmarks when it comes to Copilot Workspace. One such benchmark is a file selection benchmark. And I want you to focus on this table here. I'm going to increase the font size. What you see in this table is that we have a file selection benchmark run where we used 300 GitHub issues corrected from open source repositories. And we were running Copilot Workspace on these issues to see what Copilot Workspace selects as relevant files. Now, these issues were curated in a way that they also have a companion PR. So these are solved issues. And this is important because the PR will give us the expectation, what files should be changed. So you can see here that 5 issues, when we were running Copilot Workspace on them, they had a runtime error, so we discard those. That leaves us with 295 files, 95 issues, sorry. And then we are measuring a bunch of things. The first one is initial selection, number of experiments where all expected files are predicted. Really what we are interested in here is to know the prediction that comes out from Copilot Workspace, whether that covers all expected files or not. It's OK if it is actually a superset, but we want at least the expected files to be there. You can see that this happens roughly 37% of the time. This is when Copilot Workspace made a perfect prediction. This is not necessarily a high number, but this is just one benchmark run. And I will show you later how we actually tune the file selection to get to a better number. Now, there's this other metric here, average coverage. When it comes to statistics, this would be called recall. Essentially, we are measuring what is the ratio of the files that are actually covered on average, given the expectation. You can see that this is roughly 56%. Then we have here this other table where we are measuring runtime metrics, essentially about Copilot Workspace. I'm not going to go through this table. I just want to show this one here, appearance of the first token from the model output in the specification. Remember that this was the specification here in the beginning, this part here. So essentially what this number tells us is that it takes average 25 seconds for the user to retrieve the first valuable token in the specification. And the specification is important to us because this is like the first real point when the user can chime in. So that takes 25 seconds on average. OK, going back here. Here's an idea how we could improve file selection. We use a command line tool. It can be called Ancient, but there's actually an actively maintained version of it. It's called ctags. It's a command line tool. You can essentially give it a source file, and it will extract symbols from that file. Names of classes, function declaration, variables, and so on. between the square brackets on the screen, you can actually see the symbols that CTEX could extract from those files. There's a lot of garbage symbols, maybe because the file is dummy, but also there are some files where we can actually extract some useful symbols. And again, now you can see here a modified version of the prompt where we are using these symbols to give essentially a hint to the model to see inside those files what's going on there. This way, we actually allow the model to come back up with a more informed decision about which files could be relevant. So when it comes to tuning, we actually have a couple ideas. How many CTEX symbols should we include? Obviously, there's a trade-off here, because the more symbols we include, that will blow up the prompt size, but then maybe we'll get a better informed decision in the end. Then another thing is, how do we guard against garbage symbols? Here we have an idea to use a TF-IDF style ranking. This is the term frequency inverse document frequency, which is widely used, for example, in search engines to rank documents. And for us, it's important because this way we can tell apart the symbols that will help us to distinguish source files. How do we deal with large repositories? I told you that we just put all the file paths into the prompt. Well, that doesn't work always because there may be too many files, even with the large context window. So we have a divide and conquer style approach where we do subfile selection and then somehow we combine the results together afterwards. Can we do better when it comes to the integer IDs in the prompt? And so here we have an idea, how about we use hashes, or we actually ask the model to print out the full file path. What we see with that is that repetitions rarely happen, and there's no chance for an increasing or decreasing sequence. Now, I'm not going to tell you what is the best tuning option or combination of that. All I wanted to emphasize with this point is that it's crucial that we have actually automated benchmark set up for all of these things, because then I can just go ahead, tweak the prompt a little bit, modify a sentence in the instruction, and then I can quickly rerun the benchmark and see what is the percentage increase or decrease in response to that. Here's another such area, end-to-end benchmarking. Now, instead of just focusing on file selection, we actually want to take Copilot Workspace, run it end-to-end on an issue, and then measure different kind of quality metrics. Well, what do we want to measure? We really want to measure everything. We want to measure runtime, number of model requests, file selection metrics, how many tokens we send to Nuno, how many tokens come back. And then we are also very interested in how good is the generated code diff, because ultimately that is important to us developers. This is a very hard topic. We spend a lot of time on trying to figure out what would be a good approach for this. Obviously, you could think about like a simple text matching. This is very fragile. Even like a character difference will break it. We could also think about a more semantic approach where we actually parse the diff somehow and then we do a matching on the AST level. Still not good enough. What we landed on for now is called neural metrics, and I'm going to show you how that looks like in a real benchmark run. So here I have another link. So this is an end-to-end benchmark run, and there is this big table. In this table, we actually have GitHub issues that were hand-curated that are interesting to us for some reason. There's the issue, and there's a companion PR, which is important because essentially you can see from the PR what happened or how the solution was carried out. You can actually see here this share link, which is the snapshot that I talked about in my demo. This is very important for traceability purposes because given the non-determinism of the AI output, I may not be actually able to end up with the same solution like the benchmark run. So it's important that we can actually reconstruct the exact same session and then see what went wrong. That's why we have this here. Then we are measuring a bunch of things. Number of changed files. Copilot Workspace says that it wants to change 2 files, while the expectation is to change a single file. Number of changed lines. Copilot Workspace wants to change 6 lines of code, while the expectation is to change only 2 lines of code. Number of relevant changed files. Only one of the files are relevant, the other is irrelevant, given this particular issue. Runtime, this is in milliseconds, so running Copilot Workspace end-to-end took 21 seconds on this issue. Here are some debug metrics. Copilot Workspace, how many tokens were generated, tokens analyzed, number of model requests, and so on. Now, these are the neural metrics that I talked about. So what happens here, let's take the first one, diff correctness against diff. What does this mean? There is actually a legend here at the very bottom. Diff correctness against diff. An actual diff is correct if it performs semantically equivalent changes compared to the expected diff. This is what we want. ideally. So what we do here is that we actually prompt GPT-4, taking the actual diff that comes out from Copilot Workspace and taking the expected diff that comes from the PR itself, and we're asking the model what it thinks about that, judge it, essentially. We do this 5 times for every one of these cells, and then we're asking the model to come back up with a score from 1 to 3, and then we average over those scores. This is not perfect, because of course there's non-determinism in the output, but we have experimented already a lot with, for example, the range here. We started with 1 to 10. That was very flaky. Now we landed on 1 to 3. All I wanted to show you with this is that we are very interested in this kind of stuff, and I'm happy to talk to you about these kind of things. So this is an active area for us. Really, the purpose here would be that we have an automated way of telling how good the Copilot Workspace output is. Let me just show you another one. Plan actionability. An actionable plan provides important and useful information to know what steps to take next. Again, we just ask GPT-4 to judge this. This list is essentially extensible, and so is the list of issues that we use here. Sorry. It's important because essentially, as Copilot Workspace evolves, we would like to maintain the list that we have here, the curated issues, so that we can cherry pick issues that we find important or where Copilot Workspace doesn't work well yet. We also come up with an overall assessment based on the metrics. There's some cost function to do that, not important, but essentially you can see we have a red, green light for each one of these issues, and the overall success rate is 42%. Now, one last thing that I would like to show you here is that I can actually go to a concrete PR in Copilot Workspace itself, and then in the context of the PR, I can actually do an end-to-end benchmark run with a / command. So what this will do is that it will run the end-to-end benchmark using the 5 changes in the PR, for example, my prompting changes. It will run the end-to-end benchmark, and it will compare that to the latest nightly run, thereby giving me an idea about the impact of my code changes. To summarize all this, I started with a demo of Copilot Workspace in the web client. In the meantime, I actually switched over to Codebase to run the application live. Then I talked about a survey that we conducted with real developers about their openness to AI agency and what they actually expect from these AI assistants. Then I recapped the workflow, going all the way from a GitHub issue to a pull request and how that looks like in Copilot Workspace. The developer is in control all the way, and every step of this process is steerable. Then I talked about the file selection, some fine-tuning options, how we could actually make the file selection better. And it was very important, or the purpose of my presentation here was that we have automated benchmarks set up for all of these things, which allows us to quickly iterate on the prompting techniques. The same is true about the end-to-end benchmarks. So those are serving a similar purpose, but these are talking about end-to-end benchmark, end-to-end runs of Copilot Workspace. Copilot Workspace is in technical preview right now, so I would be happy if you go ahead and actually join the waitlist. We are letting in users every day, and we are very interested in your feedback. We are active on Discord. That's where we are actually collecting all the feedback. And Copilot Workspace is going all the way to Universe, and we are just working on it based on the user feedback. Thank you for your attention. I'm happy to answer questions.
Thank you so much, Tamas. We actually have a bunch of questions,
Okay.
So very good. The first one being, and most rated, do you write and develop Copilot Workspace using Copilot Workspace?
Yeah, I hinted at this. So I myself, when it comes to front-end things, for example, I'm not too good at that. Actually, I use Copilot Workspace to do that. I mean, I do have an idea about like programming principles and architectural things, and Copilot Workspace is great at filling those gaps.
Thank you. Can it use third-party dependencies like an NPM package, public or private?
So I'm not sure here what the question is about. Is it about running the application in the code space, installing a dependency there, or instructing the model to use an NPM package at the time when it generates the code changes?
Now, that's your time to shine. Who wrote the question?
The second one, OK, yeah, you can definitely give hints to Copilot Workspace. So I didn't actually show you, but you can either modify here the plan by hand. You can either use here like a chat-style interface, or you can just give further hints to the model. This is perfectly fine, so you can do this. I mean, it's a different question, like how much the AI will actually obey that. I can't answer that in general, but it is possible to give hints like that.
Thank you. That's an interesting one here. We learn coding by doing it. Now the AI will be, sorry, we learn code by doing it. Now, where is it? Here. Now it's moving on my iPad, sorry. Actually, I could just read there, right? So we learn coding by doing it. Now the AI will do the coding, so how will we know if it's good if we don't learn coding?
That's a very good question. And so I can only speculate about this. And again, this very much resonates with the keynote from this morning. What I can say right now is that there's going to be a massive impact of this technology. That's what we see. Programming in natural language will become a thing. It's not going to go away now. And so with the Copilot Workspace itself, our vision, I emphasize that a lot. We want this to be a second brain. We don't actually want to take away everything. And so I don't think that, like, as a developer, you won't need to spend time on understanding programming principles and how to actually program, because you will need to judge the output of the AI. So I think there's going to need to be a balancing act here.
Do you think that new coding languages will be developed after AI is going to be
English, the new coding language.
Yes. All right.
By the way, I don't know, sorry, just another comment. Copilot Workspace is actually good at talking to you in another language. So I don't know if I could demo it to you right now, but I know people have used Copilot Workspace in Chinese, for example, to get the output in Chinese. So maybe it's not just English.
That's great. If you share your Copilot session to your colleagues, when the PR is submitted, whose will it be?
When the PR is submitted. I mean, the PR itself will be created in your name. It's just, the sharing link itself will show up in the comment itself or the PR description, but it's going to be your PR.
Okay. Princeton's SWE bench is becoming the standard for evaluation coding agents on realistic tasks. Is Copilot Workspace planning on announcing a score order evaluation, I think, right?
Yeah. So, yeah, and I see the question. So it's actually super fresh. A week ago, we actually integrated SWE bench into the file selection. So I'm not going to show you numbers about that, but we are actively working on this area, and we are actively looking for other sets of benchmarks as well. For now, I mean, maybe in the future we'll actually, show our scores for the end-to-end benchmark run. But for now, file selection is so important to us that that's why we are using SWE bench for now.
Thank you. When visiting the linked session, will someone else see the updates to the descriptive steps for the model, or only the updated code step by step?
They will see the plan, specification, code changes. So everything that you don't see my screen, but everything that you could see in my session, so all the timeline elements, those will be reconstructed as well. It's not just the code changes.
In your experience, is developing with help of Copilot Workspace actually faster than doing the coding yourself with the help of Copilot?
It's a very good question. So if this is an area that I don't know too much about, then I think Copilot Workspace is doing a tremendous job. If I'm, for example, working on, let's say, the file syncer, because that was my thing, many times I actually opted just to develop the code on my own by using the first generation of Copilot. As Copilot Workspace will become better and better, maybe this trend will actually shift.
Thank you. How does the Copilot Workspace perform on large, complex code bases? Does performance depend on the size of the code base?
This is a really good question. So it is, again, an active area that we are working on to enable Copilot Workspace use on very large repositories. Our benchmark is GitHub, essentially the GitHub implementation. It's a code base with, like, I don't know how many millions of lines of code, millions of files, and so on. We are not there yet, but it's an active research area. And another thing that I want to mention here is that, can you just show my screen, please?
Can you switch the screen?
So when I was generating here the code changes, probably you couldn't see because it was fast enough, but really when we are actually asking for the model to print out the entire rewritten file contents, this can be inefficient, obviously, for files with thousands of lines of code. This is super slow. Asking the model to produce diffs is obviously possible, but there are a lot of technical challenges that come with partial file rewriting. So we are also actively working on that. It's going to be an awesome feature. It's going to come with an amazing performance boost. It's on the way.
Thank you. Copilot's training set dates back to September 21. Any plans to update it?
You mean, is it about standard Copilot or Copilot Workspace? I mean, I guess it's about Copilot, and I have no information about that. So the Copilot team is a different team. They are doing their thing, and I'm pretty sure they are actively investigating when they can update to the latest and greatest.
Thank you. In the demo, it took around 5 to 6 seconds for Copilot to regenerate the updated file, around 50 lines. Would it take 500 to 600 seconds for 5,000 lines? How scalable is this model?
Yeah, this is exactly what I just talked about regarding the partial file rewriting, which is not happening right now, but it's coming. And so because of that, it's a perfectly valid observation that for large files, this is not going to be fast.
Thank you. Will Copilot Workspace become available as a VS Code plugin instead of a web client?
We get this a lot. Other people are also interested in this. We actually do have a Copilot Workspace plugin in VS Code, but it's only for internal use at the moment. Maybe it will come. I can't comment on that.
Right. Can you tell Copilot to make the contributor handle be accessible rather than telling it to use a specific color?
Sorry, what was the question?
Can you tell, is the second one now.
To be accessible, maybe. I guess, so accessible here means like all sorts of accessibility things so that it's like right contrast and everything. I guess that was maybe the question that relates to that. I don't know, maybe we can give it a try. So if whoever asked that question, come to me here after the presentation and we can give it a try.
We really encourage you, if your question is really specific, just find him afterwards. Given a microservice architecture, can you provide hints about contents inside another repo?
Another repository. Okay, that's interesting. I mean, you can give the hint, but I'm pretty sure it's going to be completely ignored because that's not how the design of Copilot Workspace works right now. So.
How about Nightmare Spaghetti legacy code? How does it handle it?
Honestly, this is something that we would be interested in about hearing as feedback. So I don't know. I mean, more people try it out and give feedback. We can make the better we can make it. So. Okay.
Can Copilot Workspace keep architectural and coding consistency? Follow common team guidelines. Follow principles. Example. DRY case solid.
Yeah, so this is yet another thing that we hear a lot, and this is yet another thing that we're actively working on, so that you can essentially put Copilot Workspace's radar on a file that is telling it about the code style, for example, so that it obeys that better. It is coming.
Tamás, first of all, thank you very much. Let's give him a round of applause.
Thank you.